First, let me say that the quizzes assignment that you were given yesterday to review, you must do that before you do these. It is not an optional thing, it is required. And only 20 people out of about 35 of you actually completed that. So go back and do that first before you actually watch this. Excuse me. Okay, so a periodic table will probably be helpful to you eventually here, but these two papers are definitely what you want to look at. And we have this paper that you colored in before Christmas break, that is essential, and this is a big part of the reason that we did that. Okay, so recall that electrons are added to the periodic table as their energy increases. So we can say that the electrons in 1s have less energy than the electrons in 2s. And the ones in 2s have less energy than 2p, and so forth. And that ties in with your note taker from yesterday dealing with the Aufbau principle, that the lowest energy levels have to get started first. If you go back to the note taker on quantum numbers, we always start with 1s, right? It doesn't matter what element we're talking about, we're always going to fill the first s orbital first, and then we're going to 2s and then 2p. And also recall that energy can be reflected not only by the energy level shown by these numbers 1, 2, 3, 4 represented by n, but the energy can also be reflected in the shape of the orbital, right? Letter L. And that's how we get the S's and the P's and the D's and the F's. Okay, so let's get started on completing this. So this is just another way of looking right here. This diagram is another way of looking at this periodic table, okay? In other words, our lowest energy, this is increasing energy here, our lowest energy is in our orbital 1s, okay? And then the next higher energy is in orbital 2s, and after that it's 2p. And then we go to 3s, and then 3p, and look here, it's 4s, then 3d, then 4p. So I'm going to swing you over here just to refresh your memory. It's 1s, then 2s, 2p, 3s, 3p, and we have a 3d, but it's down here. Remember we were talking about like the junior high kid playing on the junior varsity team, okay, or being boosted ahead a grade. So our 4s has a little bit more energy than 3d. 3D then has, less energy than 3D. 3D has less energy than 4P. And that's what's being illustrated right here. Same exact principle, just showing you in a little bit of a simpler format maybe, especially whenever it comes to answering these questions. So if we look at question number 1, which orbital will be filled first? This ties in with the Aufbau principle. Always fill your lowest energy levels first. So it says, will 2s orbital or 2p orbital be filled first? Which one has less energy? We can look here at 2s and 2p, and we see that 2s has less energy than 2p. You can also look at your periodic table, and as long as you read it like a paragraph, and always start at the left over to the right, you'll always hit the lowest energy levels and then keep increasing energy. So again, you can see 2s comes before 2p, so it has less energy than 2p. Okay? So the energy level, or the answer for the what is going to be filled first, or the lowest energy level, we can kind of infer that is going to be 2s. So I would write 2s. Because 2s, again, has less energy than 2p. Okay, how many electrons can fit into an orbital? Well, we've been saying that. I think you all could probably tell me in your sleep. Any orbital can only hold a maximum of 2 electrons. And that's where we get our plus 1/2 and our minus 1/2, or when I was showing you the orbitals, you know, the two arrows go two different directions. All right, next, how many orbitals are there in any given S sublevel, P sublevel, or D sublevel? So again, you can use this paper. This is representing an orbital. Remember, all of our S's only have one. And if you recall our letter M, where we're looking at like 0, -1, 0, +1, -2, -1, 0, +1, +2. Remember that? So this is representing the S, right? So there's only ever one specific orbital at any given energy level for S. And then for P, there are 3. And we can see that over here too. 1, 2, 3. Whoops. So that is 3. And then for D, we would use this. Each one of these being an orbital. Again, we can look over here at our Ds. There are 5 dashes. Each dash is representing an orbital. So we would say there are 5. Okay. How many electrons are required to fill only and all 2p orbitals? So that means we go to the 2p orbitals. How many electrons will it take? Well, if we have 3 orbitals and each orbital can hold a maximum of 2 electrons, what's that's answer going to be? 3 times 2. Hopefully you're telling me it's going to be 6. The next question. How many electrons would it take to half fill the 5f orbitals? Okay, remember there are 7. Oh, hold on. Sorry, had a dog lying on my broken foot. Okay, so we're going to go to our F's. And if you don't recall, F's are going to go from -3 all the way up to +3. That gives us a total of 7 orbitals. We can also look over here, and our F's, we can count 1, 2, 3, 4, 5, 6, 7 orbitals. So if each one of those is half filled, okay, if we'd put 1 electron in each one of these, plus 1/2, remember you can only put 1 electron in each orbital before you go back and pair them up. And we talked about, you know, wanting to have your own bedroom, for example. So anyway, if we took all 7 of those and we only put 1 electron in each, how many electrons would that be to half fill a 5f orbitals? That would be 7. Which orbitals are higher in energy, the 6s or the 5d? So 2 ways you can look at this. You can say, here's my 6s and here's my 5d. Which one has more energy? We can see it's 5d. Okay, so I'm going to say 5d, 5d, but you're not going to have the, hold on, Mace, you can't lie on my foot. You're not going to have this handy dandy chart whenever you take your test, for example. So this, again, lays it out kind of neatly and simply, but if you have to, you know, just knowing how to read this or how this is all set up, because you will have to understand this for the test. You will not get this for the test, but you will have to know this is 4S and this is 3D and this is 4P, etc. Okay, so anyway, my question was 6S or 5D. Again, 6S comes before 5D on the periodic table, so that means that 5D has more energy than 6S. All right, which orbitals will be filled first, 5D or 5P? Again, look over here. Here is 5D way up here, and here is 5P right here. So if we look at this, showing us increasing energy, 5D has more, 5P has less. Again, you can use this. Here's 5D, and here's 5P. 5P comes before 5D, so 5P has less, 5D has more. Okay, so the one with less energy gets filled first. So that's going to be 5p. Which orbitals have the highest, or highest in energy? Sorry. 4d, 5d, or 4f. 4d, 5d, or 4f. Because I have this all marked up, I'll go down to this diagram. So again, my options are 4d, which is right here, 5d, which is right here, or 4f, which is right here. So which has the highest energy? Again, if you look at this, it's up the highest, so that's going to be 5d. And again, we could refer to this, and here's 4d, here's 5d, and then here's 5f. Okay. Wait a minute, that's not right. 4f, sorry. 4f. And these two would go in here. That's where they would get sandwiched in. And again, you have that on the other side of this paper. And you have that colored in. So you could use that, and you would see that you would fill 4D. Then after 6S, it would go 4F, and then 5D. Okay? And if I'm going too quickly, please pause the video and get caught up. Okay? Absorb all the information here. Okay, 2 more to go. How many electrons are needed to reach the orbital 6d? How many electrons are needed to get there? Wow, so this is going to take a little bit of math, but if we need to get to 6d, that's here. Okay, so one of the lots of different ways you can go about doing this, and using this paper that is easily at your disposal, all you would have to do is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. That's 40. How many do I need here? Where am I trying to get to? 60. Okay, so 60 isn't on here. Okay, so that's 40. Then we go to 7S. That's going to be 41. Then 42, 43, 44, 45, 46, 47, 48. We're looking at 48 there. And that takes me to 5F. And so 5F is right before 60. And so it would require all of those. So that's 48 orbitals. And if each orbital is filled, that's times 2. So it's going to be 92 electrons. Whoops. And finally, which orbital has the lowest energy? And that's this little guy down here, our little 1s. Okay. So that's how we figured that out. I will have another one ready for you to work on now that you've hopefully understood what this is. And if you don't, call me. Mrs. Turner has my number. You're going to take the time right now. And if you have a cell phone that has Verizon, you can get service and call me, or you can call me from the school, my classroom phone, so that you get this straightened out. Okay? Alrighty.